Hello, this is Kelly Hill, editor for Test and Measurement with RCR Wireless News. Welcome to Carrier Wrap. Have you ever wondered what holographic beamforming is? Brian Deutsch, who is CEO of Pivotal Communications, is here to explain. That interview after this. Welcome back to this episode of Carrier Wrap. In this episode, we talk to Brian Deutsch, who is CEO of Pivotal Commware, on the use of holographic beamforming in networks. So let's take a look at that interview. All right, this is Kelly Hill, technology reporter and editor for Test and Measurement at RCR Wireless News. I'm here today with Brian Deutsch, who is CEO of Pivotal Commware, and we're going to be discussing some of their technology in terms of software-defined antennas and holographic beamforming. So how are you, Brian?
I'm very good. Thanks for having me on, Kelly. Really appreciate it.
Absolutely. So why don't you give us a quick introduction to Pivotal Commware and what you guys do?
Absolutely. Again, super excited to be here and explain to you about holographic beamforming. So this is a technology that we've created that allows us to harness and shape and control radio frequency energy and create, in essence, software-defined antenna. And these software-defined antennas not only have super high performance, but incredible advantages in terms of cost and size and weight and power draw over more traditional legacy technologies like phased arrays or MIMO.
And so do these typically get installed in an array, or, tell me a little bit about how these actually, what's the equipment look like?
Absolutely. So, and that's the beauty of it. And again, inside that envelope of cost, size, weight, and power, these antennas actually don't look all that much different in millimeter wave than something like your smartphone. Super thin, flat panel. They use mostly off-the-shelf components. The technology actually was born out of an understanding of optical holograms, which is why we call it holographic beamforming. And optics are electromagnetics also, right? So light is also electromagnetic. And the idea of actually putting a reference wave through a holographic plate and forming an image isn't all that different from forming a beam from an RF signal. And we were able to expound on that and also take a lot of time to make sure that we could have demonstrable technology that was already reduced to practice and value engineered for applications in radio access network, backhaul, front haul, and fixed wireless millimeter wave. Our antennas span all the way from kind of low gigahertz PCS band, AWS band 41, all the way up through CBRS and into unispectrum, all the way up to 60, 70, and 80 gigahertz. For us, the 5G has just been kind of an incredible gift to Pivotal Commware, just because we have a situation where our wheelhouse, so to speak, is really in that 28 and to 39 gigahertz range. And there's a lot of things we can do in terms of beamforming to advance the capabilities of those fixed wireless systems, say like the article you just did on low E-glass. For us to be able to put very similar to what you described, except have a true, very narrow beamformer that can put a lot of energy, focus a lot of energy, and pull a lot of energy off a donor site, and then re-radiate that back into a home, all the way down from almost to, plus or minus 90 degrees. What that does is allows the carriers to space the base stations much further apart, rather than having them almost directly across from the house or off 10, 20, or 30 degrees. They can go 60, 70, 80 degrees off. So, there's a lot less hardware for them to actually go ahead and deploy this type of system. That's one use case. We were really born out of the need for carriers to maximize throughput and increase spectral efficiency. So the way to do that, we've used time and frequency. We've controlled those resources a lot since the dawn of 2G. So we've continued to kind of refine that capability. Now we're to the point where we have to conquer space. And it truly is, to pardon the pun, the final frontier for us to, get everything we can out of space. And so what this enables us to do also, if you add machine learning, if you add artificial intelligence, now you have all the levers you need to have truly self-optimizing networks. I mean, we talked about those in the past, but if you have a situation where, I'll give you another use case, where in 4G even, you have a crowd all of a sudden develop at a protest or a rally or what have you. And that crowd happens to develop right on a cell border. So now you have intercell interference from one or two or maybe three different cells that are competing for these people. And it was never contemplated that we were going to have great coverage in this zone. Usually carriers go to, they do the best they can to create these cell borders in places where people usually don't congregate. But a dynamic situation, you have this. For us, it's taking those key performance indicators back into a neural, machine learning, and then reallocating the gain of all the antennas and repositioning the gain of all those antennas. So you have a situation where within seconds, you can allocate spectrum where you need it, when you need it, and provide that directivity on demand, as we call it.
And so is that in both a macro cell and in a small cell context? Because when you talk about cell borders and, and folks congregating, very quickly, I think of something like, okay, Philadelphia, post Eagles, and I don't know if there were specific small cell deployments there, but, in a situation where you had a large crowd like that, you'd run into a lot of inner cell borders, in a very concentrated area.
Yeah, no, that's actually a spectacular use case, because there you have a situation where people are tailgating and they're in the bars and restaurants, outside the stadium. So if you focus all your attention on what's going to happen inside the stadium and you've statically controlled that and all the people are elsewhere pre-game and post-game, then you have to cover the post-game parties and things like that. You have a situation where you need that allocation to be dynamic. So bringing in cows, cell on wheels, and putting up towers, well, that's great for one specific use case, but you need this dynamic and flexible capability. So what we can do is take small cells. For the macros in a true het net, which you've talked about at length in some of your past articles, in a true het net, you have the macro kind of carrying the weight and buoying, and then the small cells coming in underneath, providing that spot coverage when and where it's needed. Well, nowadays, they really have a hard time doing that because, again, they have static antennas, so space is not controlled. We have a situation where if we have an adjacent cell and we need an assist over here because there's a congregation, that small cell can now direct that energy on demand over to that congregation of people. And then when they move on, it goes back to wherever they want. Another example of that, by the way, is, and this can be done on an annual basis because, foliage changes and things like that. It can be done on a seasonal basis. It can be done even on a daily basis where you have a traffic pattern, say, in a...
Oh, yeah.
So in an urban canyon, you have buildings, and this is a really vexing problem because of multipath. So what you can do is take a small cell, and our antenna, again, we're talking about something that's, maybe less than an inch thick, and it could be the size of a billboard. You wouldn't know it. It's up against a building anyway. And then we can actually create any hologram we want. So if we create a hologram of a bow tie beam that goes up and down the street to hit all the pedestrian traffic from, say, 5 a.m. to maybe 9 a.m., and then at 9 a.m., we switch it up into the buildings where the people are. And we just follow the people all day long with this, with this capability. So it is truly on demand. And the same thing applies, by the way, to, stadiums and high density applications like arenas, because those are fairly flexible too. The problem with DAS is you set up a venue. We've talked with a lot of venue owners, and their frustration is that you set up a venue like for the Super Bowl, and then the next day or a week later is a rock concert. Well, guess what? There's no coverage on the field because at a football game, they don't really care about the field. If players...
Well, I have to say, they did this year. That they had the Metsing balls specifically for that case. So they're starting to think about it more.
They absolutely are. Yeah, no. And 5G, by the way, and it was one of the things I know we were talking about discussing. 5G is doing some heavy lifting there also, right? So, new radio all by itself gives us, kind of more granular control over time and frequency. Mm-hmm. So for us, the subcarriers can shrink down, the TTI can, the transmission time intervals can shrink down. And so you have more granular control. So they're doing a lot of heavy lifting to get to, they're talking about maybe millions of users per square mile, where it used to, we talk about thousands of users per square mile. So that's amazing all by itself. We have new spectrum coming on, so whether it's CBRS, LAA, millimeter wave, wherever that new spectrum comes from, that's helpful too. But beamforming really, to me, kind of is foundational to what's going on inside that type of high density use case. And that high density use case, by the way, is kind of a microcosm for outside the arena too, in terms of urban coverage. And what I mean by that is, we could have a beamformer that fades into the facade of the building. So architecturally, it has zero impact. Literally, again, it would look like a picture on a wall. It could actually be a billboard. It could actually be advertisement. And what we'd be able to do is, position the energy sector by sector and putting the inner cell borders, basically in the aisleways where people walk. And yeah, you can do this type of stuff. And then, interestingly enough, you can actually provide the capability very flexibly. If people are all of a sudden on the field and need to cover it, you can do that dynamically. And again, with assisted and kind of machine learning, you can do it without human intervention.
Mm-hmm. Now, do you guys focus primarily on antennas on, say, on like a base station context, or do you think about the devices as well? Because things like angle of arrival / directionality is something that I hear over and over that will become more important, particularly as we look at 5G and millimeter wave. And I'm just curious your perspective on meeting that challenge.
The millimeter wave, yes. So, our antennas are reasonably sized for millimeter wave, and absolutely, we'll be able to do that. And we'll provide a lot of granular and finite control, over, again, that spatial corridor. So you'll pick up as much game in the link budget on the handset side as you can on the base station side. For sub 6 gigahertz, there's not a lot of value we can provide there on the subscriber equipment side. If we have a little more space, if it's more of a fixed, communications. And then of course, the other thing is for like front haul applications. At 28, or if you have millimeter wave spectrum and you have a stranded small cell and you have dark fiber and you're doing CRAN, you're trying to connect these two together. The ability for us to be able to actually have an antenna and a radio on a pole that could launch CPRI, in air, basically across. It only has to go 1,000 feet at most, maybe 100 feet. So it could be actually just meters away, but getting permits and, in New York, they're paying $500 a foot to lay fiber at this point in time. So I've heard Austin's up to maybe even 1,000 in some areas. So there's some crazy costs. That's after 3 years of permitting to get it through. So those applications we're also working on. I would also say we have 2 other applications that might not be of interest to your viewers, but just to kind of give you a better feel of all the use cases for us. 2 other vertical markets for us are what we call access and motion. So we started out doing air to ground systems. So we get planes. And again, having that ability to make an antenna that can blend into the fuselage and provide better aerodynamics, and then also have a ground station that could track the airplanes in real time. And it could be shipped to shore, it could be connected car, it could be drones. So, that capability. And then the other one is tactical communication. So I think it wouldn't take a lot of imagination to figure out what the military would want to do with this technology.
Yeah, absolutely. Interesting stuff. So I guess my final question for you would be, what do you see happening in 2018? We have, I think there's a lot of folks ramping up to 5G in 2019 and even in 2020 timeframe. A lot of tests and trials this year. What do you see in terms of what is likely to happen in the industry this year?
Well, from the industry perspective, I think it's all things fixed wireless. I think both Verizon and AT&T will be leaders. Although AT&T is saying more and more about talking mobility and mobility at millimeter wave. I think we're going to have to redefine what mobility means.
That is a very honest answer, I think.
Yeah, I think we're going to have to maybe call it portability, maybe more than mobility, and because. Especially in as much as if you wanted to do well, MIMO isn't really a technology that works up in millimeter wave, but for various reasons. But channel sounding is very difficult in terms of a millimeter wave, because such a short wavelength, you can have such a profound effect just by moving your head back and forth.
Yeah.
For us, we have a much more analog beamforming nature. So as long as we know where the handset is, which we do nowadays, they all have GPS in them. I know where the base station is. I know what beam to shoot at it, and for a line of sight shot. And let's face it, with millimeter wave, you're not going to get much in terms of multipath, unless you're purposefully, putting up reflectors to make that happen. So this year, I think what you'll see is the usual smattering of some carriers calling things 5G that aren't. And that happens, and we understand the reasons for it. And so I'm sure we'll see some at the Olympics with SK, and then other people are doing different things. People are going to call different parts of the spectrum 5G, whether it's 600 megahertz or 2.5 gigahertz, and some at 28 and 39 gigahertz. And some people will call CBRS 5G. And but realistically, to hit the goals, kind of the trifecta of gigabit plus lengths, 1 millisecond or less latency, certainly high availability and density too, in terms of 1 million users per square mile for IoT, but also for increased user density, and have that flexibility and capability. I think this year you'll just start to scratch the surface. We're a big participant, actually, believe it or not, even though we're a startup company, but strong funding from Thermal Corporation, the power behind Global Star, and Bill Gates is a huge investor in us, and Bill and Melinda Gates Investments. But for us, we're actually quite a voice for beamforming on 3GPP, and it's amazing. I mean, hey, who are those guys in the corner we've never seen before? And that's what's funny, is that I've been an electrical engineer and a radio engineer pretty much my whole life, and an entrepreneur for quite a bit of it also, and led a lot of RF startups in millimeter wave and broadband wireless access and other things. And in the old days, the antenna was basically the slave of the rest of the radio. The rest of the radio would say, all right, here, we're going to take DSPs and we're going to pack a bunch of bits per hertz in here, and then we're going to deliver it to this antenna, just shoot it out in the world. And the antenna would say, yes, sir. Now the antenna turns and says, hold on a second, I'm way smarter than that now. Who am I sending this to? And then, well, how much gain do I need to give to this person? And, what does the beam fidelity need to look like? And what does the beam pattern need to look like? What do I need to avoid? Do I need to put a null on another donor site that could be a possible interferer? So now that whole model is getting shifted. And so we're a big part of, what that protocol is going to look like into the future.
Okay, great. Well, Brian Deutsch, CEO of Pivotal Commware, thanks so much for your time today. All right, some good stuff in there. I certainly learned a lot. Now I wanted to go on to an interview from the recent International Wireless Communications Expo in Orlando, Florida. I spoke with Dave George, who is president of Pryme Radio Products, and we covered a lot of ground. Pryme makes accessories for LTE devices for public safety and IoT applications, and Dave George has a unique perspective on some of the public safety trends that are going on. So let's take a look at that interview. This is Kelly Hill, technology reporter with RCR Wireless News. I'm here at IWCE 2018 with Dave George, who is president of Pryme. Tell me what you guys just introduced at the show this week.
Well, we've introduced a number of things, but the thing that I think we're most excited about is what we call the Pryme Pico, which is our first wired headset for smart devices like Apple devices and Android devices that has the ability to trigger and manage the push-to-talk command for a POC app by directly communicating into the device with a digital signal. Okay. So actually inside, this is a Pico here.
You have it right there.
Yeah. So there's actually a microcomputer inside of this, and when it talks to the phone or the tablet, it sends digital messaging into that tablet, which can trigger the push-to-talk command of the app, like the POC app. And in the past, this was very difficult to do because of hardware limitations of the way the phones were designed. Yes. Especially on these consumer phones, they don't really have a dedicated push-to-talk wire, if you want to think of it that way. Yeah. So it took us a little while, but we figured out a way to reliably trigger that push-to-talk command. And that's going to be super nice for our customers, because there's no more of the like with the Bluetooth devices, it's kind of complicated. You have to go into the control panel, you have to pair them, you have to link them, you have to keep them charged. And when you have a large number of users, like in a hospital, hotel, university, or something like that, it's just much easier if you have something that just plugs in and works. So that's what the Pico does. Just plug it in and it works. Yeah.
And you designed this originally for like a hotel use case, yes?
Well, I gave you hotel as an example because it's a real example of one customer that we had that bought a lot of Bluetooth, hundreds of Bluetooths, found out that it was just unmanageable, and then asked us to come up with a solution. That was about 2 years ago, and of course since then we've seen many others that have come forward. And I think this is just the first iteration of this because this is something people wanted. It's a surveillance kit, with a classic Secret Service thing.
Yep.
But we can actually change the top of this to 5 other different kinds of earphones. But I think in the future we'll probably just take this technology and we'll put it into a speaker microphone, we'll put it into a motorcycle kit, or into all kinds of headsets and stuff like that, whatever people want. I mean, the one thing we try to do at Pryme is we just basically build what people want. That's our thing. We don't try to invent something and then convince everybody they should buy it. We have a lot of customers and they're constantly saying, we wish you could do this and we wish you could do that.
Now, what impact do you see LTE and FirstNet having on devices and accessories for public safety?
Well, I'm as a technologist, I'm an engineer. I do believe that it's coming and it is going to be deployed in large quantity. LTE is such a broad term. I really kind of can translate that to just saying whatever at the time is the best broadband technology that's currently out there. It'll be LTE, maybe it'll be 3G, 4G, 5G, 11G, don't really know. But it doesn't really matter. It's like with our phones. We don't really care what the technology is. What we care about is how fast are they and what services do they provide. So I do think that the beauty of the FirstNet initiative is that it brings together this large opportunity that's going to create enough of a marketplace that it's going to attract a huge amount of investment by manufacturers to develop hardware and to develop software. And so I think it will come. I think all of the issues that will come up along the way, and there'll be a lot of them, will be resolved. I don't know how long it's going to take, but I do believe it will be resolved, just like it is in cell phones. We all have one today, and we all couldn't live without it. I think we're going to see the same thing with FirstNet.
Okay. Well, Dave, thanks so much for your time. Really appreciate it.
Yeah, well, thanks so much. Okay. Appreciate it.
Bye-bye.
Thank you, everyone.
And that wraps up this episode. Thanks for watching, and I'll see you next time.